So this first problem, they're telling you one of the legs of a right triangle, and they're telling you the hypotenuse of the right triangle is 6, and you're being asked to find the sine, cosine, and tangent of the two acute angles of the triangle. So the first step is going to be to determine what this missing side of the triangle is going to be. So we're going to use the Pythagorean theorem. Remember, you can only use the Pythagorean theorem if you have a right triangle. And the most important letter in the Pythagorean theorem is letter C, the hypotenuse. So in this case, letter C is going to be 6. So we're going to have 6 squared. A and B are going to be the 3 and the x. Doesn't make a difference if A is 3 or B is 3. Here we're solving for x, so 3 squared is 9, plus x squared. 6 squared equals 36. And now to solve for x, we're going to subtract 9 on both sides. We have x squared equals 27. We're going to take the square root of both sides. So here, x is going to be equal to the square root of 27. And in a perfect world, 27 would be a perfect square, but unfortunately it's not. So what we're going to do is we're going to try to simplify radical 27. We're going to look for the largest perfect square that goes into 27 evenly, and in this case it's 9. So we're going to break up radical 27 into radical 9 times radical 3, and the square root of 9 is a perfect square, so that's the number 3. So here I'm left with 3 radical 3 for this missing side of the triangle. So this leg of the triangle is going to be 3 radical 3. Now we're going to go about finding the sine, cosine, and tangent of angle A. Remember, trigonometry is all about whichever angle you're dealing with. And here we're dealing with angle A. So I'm going to label the picture with angle A as the perspective. Here, the opposite side of angle A is going to be 3 radical 3. 6 always stays as the hypotenuse, which means when you're looking at this triangle with angle A as the perspective, it looks like here 3 is going to be the adjacent. So I'm going to write out SOHCAHTOA, and here it is up here. The sine of an angle, the SO, that's going to be equal to the side opposite divided by the hypotenuse. Here the side opposite we said was 3 radical 3, and the hypotenuse was 6. So here it looks like my answer is 3 radical 3 over 6, but I'm going to cancel out. 3 goes into 3 once, 3 goes into 6 2 times. So here I'm left with 1 radical 3, or radical 3, over 2. So that's what our answer is. That's what the sine of angle A is. The cosine, the ka portion of SOHCAHTOA, that's equal to the adjacent over the hypotenuse. So here the adjacent we said was 3, the hypotenuse was 6, and 3 over 6 reduces to 1/2. Here the tangent of angle A, that's the TOA portion of SOHCAHTOA, that's equal to opposite over adjacent. So here our opposite is 3 radical 3, our adjacent is 3, and then 3 goes into 3 once, 3 goes into 3 once. So here we're going to be left with radical 3 over 1, or just radical 3. So all 3 of those trig functions dealt with angle A. Now we have to do the same thing, although in a different order, the sine, cosine, and tangent of angle C. So I'm going to go and now label the triangle based on the angle, which in this case now is angle C. The hypotenuse never changes, so that's still going to be 6. But now, since I'm dealing with angle C, the opposite is going to be 3, and the adjacent is going to be 3 radical 3. So here I'm going to have the tangent of C. Well, that's the TOA portion of SOHCAHTOA, so that's the opposite over adjacent. So here the opposite is 3, and the adjacent is 3 radical 3. So here I have 3 over 3 radical 3. 3 goes into 3 once, 3 goes into 3 once. So here I'm left with 1 over radical 3. And we're going to circle that because that's our answer, sort of, or not so fast. Remember, you're not allowed to have a radical in the denominator of a fraction. So what we're going to have to do, a skill from algebra called rationalizing the denominator. Here we're going to multiply the top and the bottom by radical 3. What's going to happen? Well, 1 times radical 3 is just radical 3. Radical 3 times radical 3 is radical 9. But what is the square root of 9? That's just the number 3. So here I have radical 3 on top and the number 3 on the bottom. And that's what our final answer is going to be. That's a more acceptable form because you're not allowed to have a radical in the denominator of a fraction. Okay, let's go back. Now we have to do the sign. So that's going to be the SO portion of SOHCAHTOA, opposite over hypotenuse. Here the opposite is 3, the hypotenuse is 6, and 3 over 6 is just 1/2. And now we have the cosine of angle C, that's the CA portion of SOHCAHTOA, that's adjacent over hypotenuse. So that's going to be 3 radical 3 over 6. 3 goes into 3 once, 3 goes into 6 2 times. So here we're going to have radical 3 over 2. Do we have to rationalize that denominator? Do we have to do what we did up top here? And the answer is no. Here the radical is in the numerator, so that's acceptable. So that's why our answer is going to be radical 3 over 2. Let's try another one. So here we have another right triangle, but this time we're missing the hypotenuse. So the first step is going to be to figure out what the hypotenuse is. We'll use the Pythagorean theorem, a squared plus b squared equals c squared. The most important letter in the Pythagorean theorem is letter C. That's the hypotenuse, which in this case we're trying to figure out. So that's going to be our x squared. A and b will be the other two sides, so 2 squared and 4 squared. And we're going to solve for x. 2 squared, 2 times 2 is 4, plus 4 squared, 4 times 4 is 16. That equals x squared. So 4 plus 16 is 20 equals x squared. And we'll take the square root of both sides. So here x is going to be equal to the square root of 20. But we're going to simplify that. We're going to look for the biggest perfect square that goes into 20 evenly. The biggest perfect square is going to be 4, because 4 times 5 is 20. Why did I break it up into 4 and 5? Because the square root of 4 is the number 2, and here I have 2 radical 5. Sometimes students break up the square root of 20 into radical 10 and radical 2, but neither of these is a perfect square, so this is not going to work. We're going to instead look for a perfect square number. Remember, list of perfect squares. 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 25, 36, 49, 64, 81, 100. Those are the first 9 perfect squares. So that tells me the hypotenuse of this right triangle is going to be 2 radical 5. And now let's go about finding sine, cosine, and tangents of the 2 acute angles. First, let's label the triangle with angle A as our perspective. The hypotenuse is never going to change. It's always opposite the right angle. So in this case, the hypotenuse is 2 radical 5. But here, angle A, the opposite is going to be 4, and the adjacent is going to be 2. So now to find the sine, that's going to be the SO portion of SOHCAHTOA. So here the sine is equal to the opposite over the hypotenuse. The opposite is 4. The hypotenuse is 2 radical 5. Now you might be thinking we messed up somewhere because the hypotenuse has to be the longest side of the triangle. And at first glance it looks like 4, the opposite, is bigger than the hypotenuse 2 radical 5. But if you simplify 2 radical 5 as a decimal, you see up here, it turns out to be 4.47, give or take. So that's bigger than 4. So here's our answer. We have 4 over 2 radical 5. But now I can simplify it. 2 goes into 2 once. 2 goes into 4 2 times. So I have 2 over radical 5. And that would be my answer. But unfortunately, we have this radical again in the denominator. So we're going to have to rationalize the denominator by multiplying the top and the bottom by the radical. So here we're going to multiply the top and the bottom by radical 5. So in the numerator, I have 2 times radical 5, or 2 radical 5. The denominator, radical 5 times radical 5 is radical 25, but the square root of 25 is just the number 5. So here is my answer for the sign. I have 2 radical 5 over 5. A lot of trigonometry, you get these ugly looking answers, but here the sine of angle A is 2 radical 5 divided by 5. Let's now do the cosine. The cosine is equal to the adjacent over the hypotenuse. Our adjacent was 2. The hypotenuse is 2 radical 5. So I have 2 over 2 radical 5. 2 goes into 2 once, 2 goes into 2 once, so I have 1 over radical 5. Unfortunately, again, I have to rationalize the denominator because I have this radical in the bottom of a fraction. So I'm going to multiply both the top and the bottom by radical 5. So in the numerator, I have 1 times radical 5, or radical 5. The denominator, radical 5 times radical 5 is radical 25. But you know the square root of 25 is just 5. So here we're going to have radical 5 over 5. So that's what the cosine is, radical 5 over 5. Finally, the tangent of angle A. The tangent is the TOA, the opposite over adjacent. So here the opposite is 4, the adjacent is 2, and 4 over 2 is just the number 2. So there we did the sine, cosine, and tangent of angle A. Now we're going to do the sine, cosine, and tangent of angle C. So I'm going to relabel the picture based on angle C. What's not going to change from before? The hypotenuse. The hypotenuse always is the longest side, so that's 2 radical 5. But now I'm dealing with angle C, so now the opposite side is going to be 2. The adjacent is going to be 4, because we're all about whichever angle we're using. I'm going to do my work down here. The tangent of angle C. Well, the tangent, that's the TOA portion of SOHCAHTOA, opposite over adjacent. Here the opposite is 2, the adjacent is 4, and 2 over 4 is a half. So I know the tangent of angle C is 1/2. Next up is the sine of angle C. Well, the sine, that's the opposite over hypotenuse. The opposite is 2. The hypotenuse is 2 radical 5. So I have 2 over 2 radical 5. But where have I had that before? The sine is 2 over 2 radical 5. I simplified that when I did the cosine of angle A. So 2 over 2 radical 5 simplified into radical 5 over 5. So I know the sine is radical 5 over 5. Finally, I have the cosine of angle C. That's the CA portion of SOHCAHTOA. That's the adjacent over hypotenuse. The adjacent is 4. The hypotenuse is 2 radical 5. But I simplified that way up top here when I did the sine of angle A. See how I have 4 over 2 radical 5? 4 over 2 radical 5 simplified into 2 radical 5 over 5. So I know the cosine of angle C, 2 radical 5 over 5. These questions can get very, very messy, but they come down to SOHCAHTOA and rationalizing the denominator.